Hi everyone. In today's class, we are going to see a topic on single tuned amplifiers. Let me recall the topics that were already dealt in our class. That is, initially we started a topic named as a tuned amplifier. The property of a tuned amplifiers are it is capable of amplifying a signal over a narrow band frequencies. And what we have learned is, if I consider the frequency response of a tuned amplifier, we observed that there were three different frequencies into our observation. First one is a center frequency named as omega naught, a low cutoff frequency that is represented as omega L, and the upper cutoff frequency that is represented as omega H. If I consider the practical response of the graph with respect to gain in dB was observed like a bell-shaped curve, and its phase response was observed at the center frequency omega naught. Now, if I consider the case of a tuned amplifier, basically a tuned amplifier can be classified into three different types. To start with, first type of a tuned amplifier is named as a single tuned amplifier, and the second category is named as a double tuned amplifier, and third one is named as staggered tuned amplifiers. So these are the three classifications of a tuned amplifiers. If I consider the classes that were discussed previously, we have seen a term named as a quality factor, where quality factor formula is represented as 2 pi into energy that is stored per cycle divided by the energy that is dissipated per cycle. So we consider this quality factor for the case of a tuned amplifier. The reason is, if we consider the construction of a tuned amplifier is basically a tank circuit comprising of a capacitor and an inductor that is connected to a resistor taken as R. So this will be the basic construction of a tuned circuit. Now what we will doing is, we used to take this tuned circuit and we will be computing the quality factor for the case of a capacitor and an inductor. If I consider the case of a capacitor term will be analyzed in two different factors. That is, when the capacitor is connected in series with the input signal, and when the capacitor is being connected in parallel with the input signal. So in previous class, so far we have computed the quality factor for the case of a capacitor that is connected in series and a capacitor that is connected in parallel with a quality factor, and the same quality factor was computed for the case of inductor also. Now in today's class, we are going to see one classification of a tuned amplifier named as a single tuned amplifier. You have to know what is the meaning of a single tuned amplifiers. So we all know that tuned amplifier is capable of amplifying signals over a narrow band of frequencies. So now what we are going to do is, we are going to consider a transistor of an NPN type, and we are going to take this transistor for our analysis that suits for a tuned application. So make a remember that tuned amplifiers are highly suited for radio applications and not an audio application. Since it suits for radio application, its frequency ranges will be lying greater than 20 kilohertz. So whenever we are processing a tuned amplifier, whether it is a small signal tuned amplifiers or a large signal tuned amplifiers, make a remember that the frequency ranges will be lying above 20 kilohertz. And what we are going to do is we are going to take this frequency to our considerations, and we are going to do an analysis related to single tune amplifier, double tune amplifiers and stagger tune amplifiers. Make a remember that whenever we are processing a radio frequency application, if we are constructing an equivalent model, that equivalent model should be represented in the form of pi model, and it should not be in the form of hybrid model. The reason why H parameters are not used is because H parameters will be supporting only low frequencies and it is not applicable to high frequencies.